Hello students, let us study about a simple topic that is about sulfur. So sulfur is actually forms different allotropes. So sulfur forms many allotropes. Different allotropes are possible for sulfur. But there are two most important allotropes of sulfur are there. They are rhombic sulfur and monoclinic sulfur. So first allotrope, the first important allotrope of sulfur is rhombic sulfur. Rhombic sulfur, which is otherwise called yellow sulfur, or it is alpha sulfur. Then second important allotrope of sulfur is monoclinic sulfur or beta sulfur. So alpha sulfur and beta sulfur, they are the most important allotropes of sulfur. So rhombic sulfur is actually stable. So out of all the allotropes of sulfur, rhombic sulfur is stable at room temperature. So we can expect a question, which form of sulfur is stable at room temperature? So answer is rhombic sulfur. So rhombic sulfur is stable at room temperature. Then let us see the preparation, how these allotropes or how these forms are prepared. So first one is alpha sulfur. Alpha sulfur or rhombic sulfur is prepared by evaporating a solution of roll sulfur in CS2. So roll sulfur is actually rod-like or stick-like sulfur, and CS2, you know, it's an organic solvent. Actually, sulfur is soluble in organic solvents. It is not soluble in water. So sulfur is soluble in organic solvents like CS2, benzene, etc. Here we are using CS2. So in CS2 it is soluble. So on evaporating the solution of roll sulfur in CS2, we will get crystals of alpha sulfur. So crystals are formed here. Crystals of alpha sulfur is formed. So this is the preparation. Then about beta sulfur. So beta sulfur is prepared from alpha sulfur or rhombic sulfur. So here melting of rhombic sulfur in a dish and cool. Here we will get needle shaped beta sulfur. So from alpha sulfur or from rhombic sulfur we can prepare beta sulfur. So we can actually convert alpha sulfur to beta sulfur and beta sulfur to alpha sulfur. So beta sulfur to alpha sulfur and alpha sulfur to beta sulfur. That conversion is possible. So it is possible by heating, that is at 369 Kelvin. That temperature is very important, and this 369 Kelvin. So at 369 Kelvin, both forms are possible. Below 369 Kelvin, alpha sulfur is predominant, and above 369 Kelvin, beta sulfur is predominant. So at 369 Kelvin, both forms are stable. So both forms are there, or both forms are stable at 369 Kelvin. So this temperature is known as transition temperature. So the transition temperature in this case is 369 Kelvin. So the temperature is important. So at transition temperature, both forms are stable. But below 369 Kelvin, alpha sulfur is stable, and above 369 Kelvin, beta sulfur is stable. Both forms are stable at 369 Kelvin, and that temperature is known as transition temperature. Now let us see the structure. Actually, alpha and beta form of sulfur, they have S8 molecule. So we have to draw the structure of alpha sulfur and beta sulfur in the same way. That is, both are having S8 molecules. So let us draw the structure. So alpha sulfur and beta sulfur both are having S8 molecules. So S8 molecules are there in the case of alpha sulfur and beta sulfur. So it is actually crown shaped or puckered ring. That is the shape. So we can draw the structure. S8 molecule. So 8 sulfur atoms are here. So we can draw the lone pairs also. So 2 lone pairs are there. So this is the crown shaped structure or puckered ring structure of S8 molecule. So S8 molecule, that is about alpha sulfur and beta sulfur. So both are having S8 molecules. Now let us see another form of sulfur, that is Cyclo S6, that is also possible. So in this case we need to know the shape. The shape is chair form or chair shaped. So this can be drawn like this. So 6 sulfur atoms are there. So 6 sulfur atoms are there. Here also we can draw the lone pairs. So this is about Cyclo S6. So S6 form, that is also possible. So this is about Cyclo S6, that is the shape is chair form. Now let us see another question regarding sulfur, that is which form of sulfur is paramagnetic in nature? That is an important question. So the question is which form of sulfur is paramagnetic? Or another question maybe in vapor phase sulfur is paramagnetic. Why? So this type of questions can be asked. So in this case we will see S form vapors or sulfur form vapors if the temperature is high, or if the temperature is high, or if it is we can say elevated temperature, at elevated temperature, or we can say it is more than 1000 Kelvin. So the sulfur form vapors. So sulfur vapors are formed when temperature is high. So at high temperature or at elevated temperature, or the temperature is more than 1000 Kelvin, sulfur form vapors or vapors of sulfur are formed in that case, and sulfur form as S2 molecule. So S2 molecules are here in the vapor phase. So S2 molecules are just like oxygen molecule, just like oxygen molecule O2, and which is paramagnetic in nature, which is paramagnetic. Since you know there are two unpaired electrons in the anti-bonding pi star orbital. So there are two unpaired electrons in the antibonding pi star orbital. So this is the same with oxygen molecule. So in oxygen molecule also there are two unpaired electrons. So it is paramagnetic. Just like S2 molecules are having two unpaired electrons in the antibonding pi star orbital. So it is also paramagnetic. So this happens in the vapor state. So sulfur form vapors, or vapors of sulfur form if the temperature is high, or we are giving elevated temperature, or the temperature is more than 1000 Kelvin, sulfur form vapors. So vapors of sulfur is showing paramagnetism. So that paramagnetism is due to the presence of two unpaired electrons. It is just like oxygen molecule. So this is the answer. These two questions are that is actually similar. So this is very important. So this is about sulfur.